Okay, so we are talking about area today. So the first couple sections, well, actually, let's rewind. Area is always measured as, what do you do with the units? They're units squared, and doesn't it make sense, right? If you look at a rectangle, and you guys know that if this is 5 meters and this is 3 meters, to find the area of the rectangle, you just multiply 5 times 3, right? Doesn't it make sense that it's going to be 15 meters squared? Right? Because look, you're doing 5m times 3m. Isn't that 15m squared? So yes, it makes sense that the units are always going to be squared because you are multiplying them together. Okay? So area, always whatever your units are, squared. Okay? So rectangle, length times width, nice and easy. It's the same thing as base times height. Who cares? Yep. Oh, sure. You're welcome. And a square is a type of rectangles, but since both sides are the same, you can just say S times S, which is the same thing as side squared. So it doesn't matter. It's all the same thing. Okay? All right. We have a couple postulates here. Congruent figures have equal areas. Well, that only makes sense, right? If I have two congruent rectangles, length times width would have to equal length times width. Let me ask you this question, though. If I have two rectangles with the same area, are those rectangles congruent? No, not necessarily. They could be, right? So here is a 15-meter square rectangle, but then wouldn't this also be if that's a 1 by 15? That would also have a 15-meter squared area, but clearly those two rectangles are not congruent. So be careful about that. Congruent figures, sure, would have the congruent areas, but it doesn't work the same way. Going backwards, yep.
Is there a name for two rectangles that have the same area but are different?
Oh, good question. Not that I know of.
Okay.
Yeah, I think it would just say congruent areas. Okay, so let's also say I had a shape that was not a normal figure. If I just had, I don't know, some random quadrilateral like this. I don't have a formula for that, so what can I do? I can break it up into multiple parts. So in this case, I have two triangles, which I do have a formula for, and I can just find the area of each triangle and add them together. Make sense? So as long as those parts don't overlap or leave any gaps, the sum of the area of the parts would equal the area of the whole thing. Okay? All right. Parallelograms. Do you know the formula for area of a parallelogram? It's still base times height, which is the same as a rectangle. Here's the thing, though. Base and height always have to be perpendicular to each other. Always, always, always. So if I gave you this parallelogram and I told you this was 3, that slanty piece was 3, and this was 5, you don't have enough information to find the area of this. You do not do slanty times the base. That's a big no-no. You'd have to figure out that is the base, but 3 is not the height. When you go to the doctor's office and they measure your height, do you stand there on an angle like that? No. Right, you have to be standing up nice, straight, and tall. You would need to find that would be your height right there. Okay? Notice that I put the height, I marked it as perpendicular to the base. They have to be. Height and base must be perpendicular to each other.
Oh my God. I'm a genius. It looks like an H.
It does look like an H. So, in this picture, I didn't give you enough information to find what that is, but let's just say I told you it was a 2. Now you know the area of this shape would be 10. Agreed? So, and then these other pictures are just kind of showing you why that works. You can basically chop off that triangle and move it here and turn it into a rectangle where it is base times height. So that's pretty cool. So just always remember, and that goes for every single shape. If you are multiplying base and height together, make sure the base and the height are perpendicular to each other. Otherwise, it's not really the base and the height. It's probably the base and some other random side. That's not the height. Okay? So that's the big deal. As far as triangles go, you all know the formula for area of a triangle. It is 1/2 base times height. Well, that's interesting. 1/2 base times height. It's the same thing as a parallelogram, only half. Do you mean to tell me that basically any triangle you can think of is just half a parallelogram? It is? It is. So, you can take a right triangle, obtuse, acute, it really doesn't matter. If you just double it and put it the right way, you have created a parallelogram. That's pretty cool. So, again, it makes sense that it's 1/2 the base times the height. Now, be careful with triangles, right? So, if you had, like in this one, again, you have to have the base and the height that are perpendicular to each other. So if I only gave you the outside edges, I don't know, say that was 6, that was 2, and the whole base was 8. No, 7. You don't have enough right now because you don't know what the height is. You're not going to do 7 times 2. You're not going to do 7 times 6. You'd have to figure out what that is. So I'd have to give you some information somewhere for you to be able to find it. If you had an obtuse triangle, and I gave you this bottom part was the base, so let's say that that's 8. Where's the height for an obtuse triangle, kind of when I draw it this way? It's out over here. Remember that? So if I just extend this, well, let me use a different color. Yeah.
Could you also, for the height there, could you draw it as like...
You could, and then you would have that as the base. So if I gave you that, that would work out. But let's say I gave you this is 4 and that's 8. So here's and this, sometimes kids get confused with this. They think that this whole thing has to be the base, including that this is not even part of the triangle. It's just extending it so I can draw yeah, so it's just this part right here, right? It's only, and any side can be the base. It doesn't have to be the bottom. It would just depend on what side you have information for. So, one full side, and then an altitude drawn to that side, basically, is your base and height. Does that make sense? Yes. Okay, good. Now, so that's all old news. You've done base times height. You've done 1/2 base times height for triangles. So what's new, probably for you guys, some of you, is this kite business. So kites, and therefore rhombus and square. So we're going to talk about a new formula that works for kites, rhombuses, and squares. You can use, now, for a square, we already have 2 formulas for a square. Side square, right? Or base times height. You can also use this one for a kite. You ready for this? It's so cool. So here's a kite. Remember what kites are? They have 2 pairs that are congruent, and then the bottom 2 pairs are congruent. Remember this? Their diagonals are what? Perpendicular. Okay, cool. So basically it's shapes that have perpendicular diagonals. I can take 1/2 the product of those 2 diagonals. So there's our formula. 1/2, let me do orange. 1/2 diagonal 1 times diagonal 2. What? Are you sure? I'm sure. Watch. Let's try with a square. So let's say I had a square, and let's just say its side length is 4. So obviously it would have an area of 16, right? So let's say its 4 area is going to be 16 units squared. Okay? So watch. I'm claiming that if, instead of doing side squared, if I figure out the diagonal here and the diagonal here, and I multiply them together and I take half, I should still get 16. Obviously, if I already know the side, I would never do this. I just want to prove to you that they are the same. I would only use 1/2 the product of the diagonals if I already had a diagonal, and I didn't know what the side was. You get what I'm saying? Okay, but let's just show that they really are the same. If that's 4 and that's 4, what's this length? 4 root 2. What would the other diagonal be? In a square, it's 4 root 2 and 4 root 2. What's 4 root 2 times 4 root 2? And then take half? Well, what do you know? Oh, so cool. So that can save you a ton of time if you just are given the diagonal of a square. Instead of having to figure out what the side is and then square it, if you just know, oh, 1/2 the product of the diagonals. And they already gave me the diagonal. What fun. Any questions so far? Everybody's okay? All right, let me know if you're stuck on anything. So again, that is for a kite, a rhombus, or a square. Don't forget, though, that a rhombus is also a parallelogram, and so is a square. A kite's not, but a rhombus is also a parallelogram, so you can still use base times height for area of a rhombus. It's all dependent on what you're given, right? If I'm given base and height of a rhombus, sure, I'll use base times height. But if I'm not, if I'm given stuff with the diagonals, I'm probably going to use 1/2 product of the diagonals. Okay, and then our old friend, the trapezoid. Anybody happen to know the area of the formula for area of a trapezoid? Adam, go ahead.
Half times base 1 plus base 2 times height.
Yes. Notice, guys, it's basically the exact same thing as area of a triangle. It's just that we have two bases now, right? Isn't it 1/2 base times height? So the thing with the bases is that since there's two of them, I'm just going to add them together. So I know at first sometimes you feel like, oh, there's so many formulas for me to remember. Well, not really, because I'm sure you all know base times height. And I'm sure you all know 1/2 base times height for triangle. So yes, this one might be new, 1/2 the product of the diagonals. And this is new, but if you recognize, hey, it really is just the formula for triangles, it's just I'm replacing the base with the sum of the two bases. Okay, now let's be clear on trapezoids. We have a nice picture over here. Bases and height still have to be perpendicular. So your bases are always going to be the two sides that are parallel. Always. It's not top and bottom, right? Because I could have the same picture just drawn sideways. So just make sure it's the pair of sides that are parallel are your bases. It doesn't matter who you call base 1 and base 2 because you're just going to add them together anyway, so who cares? But your height, again, has to be perpendicular to both of those bases. It is not going to be those slanty sides. Those are the legs. And notice this formula had nothing to do with legs, so. Okay. All right, that's basically 11.1 to 11.3. Are there any questions about that so far? No? Okay, now the one section that is kind of brandy new, and really the last one that I want to cover today is the 11.4 stuff. So if you flip it over, 11.4. Oh gosh, I love this stuff so much. So this section is all about areas of regular polygons. So let's just make sure that we haven't forgotten what a regular polygon is. What's regular mean?
All sides are the same.
And angles, yes, all sides and all angles. So it's an equilateral, equiangular polygon. So yes, your equilateral triangle is one, your square is one, and then you have one for every other shape. They would just have to be all the same lengths and all the same angles. Now, if you have a regular polygon, this is so cool, you can inscribe it inside of a circle. How neat! Now, what do I call this segment that goes from the center of my circle, which is also the center of my shape, to the edge? That's a radius. If I get rid of the circle on the outside of this, that thing is still called a radius. And that's kind of why, because I can just put it back in a circle and it's the same. So most of your problems are not going to have circles drawn around them. So if you have a segment from the center of a shape to a vertex, to any of these vertices here, right? It's still called a radius. Yep.
Is it only called a radius for regular polygons?
Ooh, that's a great question.
Well, because then the vertices won't be the same distance from each other and not regular.
Yeah, I think it does have to be, because if it's not regular, it may not be able to be inscribed in the circle anyway. Yeah, good question. So, that guy called a radius. Now, in a regular polygon, what do you suppose is true about each radius? They're all congruent, exactly. So if I drew in another one over here, guys, right, these two are going to be equal to each other and all the way around. So what I have now down here is an isosceles triangle, don't I? Yes, that's going to be quite useful to us. Okay, now we have a new vocab word. You ready?
I have no idea what it is.
Apothem. I say apothem. Some people say apothem. I don't know. I don't even know who's right. I say apothem. So, the apothem. All right, guys, you with me? So, let's make sure that we're all clear on where that is. So that's another segment that's also going to start at the center of my shape. Guys, are you listening? And then it's going to drop perpendicular to any side. So in this case, it's basically like the altitude of this isosceles triangle. Right? It's just going to go from the center, perpendicular to a side. So that green thing that I just drew, that is what we refer to as an apothem, apothem. I don't really care what the heck you call it as long as you can identify it.
I like it.
Apple stem? All right.
Apple stem with apple toast.
It sounds like someone with a lisp saying
Okay, so let me go ahead, and we've already talked about central angles, so I do have a central angle here now. If you look between the two radii, right, that whole vertex angle of that big triangle would be my central angle. We'll talk more about that as we try a couple practice problems. Let me give you the formula for area of a regular polygon, though, and then we'll kind of do some practice problems to see how you actually get there. So, everybody know it from the work that you've done? No? That's okay. Here it is. 1/2 little a times capital P. What do you suppose little a is? Yes, the apothem. So whatever the length of that apothem is, that's going to go in for A. What do you suppose capital P is? Yes, it's the perimeter of your shape. Yep.
What's the little note right above that is? Use N isosceles.
Oh, to solve, I'm going to get there.
Oh,
That's okay. So P is perimeter. Oh. All right, so for any regular polygon, that's what's nice about this. You can use it on anything. It could have 6 sides, it could have 16 sides, as long as it's a regular polygon. Who else is a regular polygon?
me.
A square. Now you have another formula for area of a square. I really don't know why you would ever use this one, but you could. Yep.
Would we ever get a question that would name all the areas, name all the formulas you use to have area of a square?
You could.
Okay. Like, is it something like, I mean, because in my head it's harder to think of, like, I can use all of these words, like, to just memorize and know what I need it for, kind of. So, like, I don't know. Should I go out of my way to, like, think, I
I wouldn't.
Okay. Okay.
Okay, so let's try a couple and see how this works. So, gosh, let's just start off with a, what shape do you want to use?
A jar.
Triangle?
A jar.
Okay, we'll start with a triangle just to make sure that we have our,
Let's start with the line. Let's do an octagon.
we're going to start with an equilateral triangle. So this is a regular polygon. And yeah, okay, you could use 1/2 base times height, but I'm not going to give you those things. I'm going to give you one bit of information. What do you want besides the answer?
The perimeter. Like one line.
One length? Okay, so let's say, what do you want it to be? Give me a number. 7.
All the numbers.
Pick an even number. 6. Okay, I heard 6. So one entire side is 6. Okay? That's all I'm giving you. Right, it is an equilateral triangle, which means now that all 3 sides are 6. So that's helpful. If you, oh, well, okay. Whatever.
The middle is 3 root 3.
Is it?
Yes, it is.
Ooh. Now, hold on. I haven't given you the height of the whole triangle, right? So you could either go ahead and calculate it out and find it. You want to do that? Okay. Yes, Dakota.
Is the apothem half the height?
No. Good question. So, I don't know if you heard what she just said. She just asked if the apothem is half the height. Not necessarily, and not in this case either. Right? So, the radius would be there. Here's another radius. Here's another whole radius, right? Another whole radius wouldn't be the same as this length here. So, is it half? I'm trying to think if there's a scenario where it could end up being half, but it's not always going to be, so you don't want to think that it is. Okay, so, if you don't, you're right that you can do what you were doing. But for the sake of this section, let's say we want to use the area equals 1/2 little a times p. Well, good news is I already know what the perimeter is. That's easy. That would just be 18. So I just have to figure out what a is. So a would be the apothem, right? So the apothem is going to go from the center perpendicular to a side. Now, what did the apothem just do to that side? It bisected it, and that will always happen in a regular polygon. So any of your apothems will bisect the side they're on. So that's 3. What else do you know about an equilateral triangle? The angles, right? What's the deal with the 3 angles? They're all 60. And what does that radius do to this angle? Bisects it, exactly. So in this case, that's a 30. So this is a special right triangle, absolutely. So if that's 30, that would be the short side. So this is the middle side. What would I do with the middle to get the short side? Divide by root 3, so that means the apothem would be 3 over root 2, which is 3 root 2 over 2. Right? Oh, gosh. Blah, 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 blah. Oh, my gosh. So silly. So that's just root 3, right? Okay. Sorry. I was thinking root 2 in my head.
I didn't understand.
Okay, so now just put all the pieces together. Isn't that just 9 root 3? That's it.
That's the whole answer.
Yep. And then whatever my units are, units squared.
What is the question to find the apothem?
No, the question was to find the area of the whole thing.
Oh.
Oh, that's
So there's the formula for area. We had to find the apothem to get there. Okay, let's do another shape. How about a hexagon? Well, that's, okay, we should have probably started there. Does everybody remember all of our shape names? Let's recap. 3 sides, of course, is triangle. 4 is a quadrilateral. 5 is a pentagon. 6, 7, heptagon. 8, octagon. 9, 10. Do you know 11? It's an 11 is the word decagon with UN in front of it. I don't know how you say it. Undecagon? Undecagon? I don't know. And then 12 is dodecagon, right? I think so, but I don't know, to be honest. I only know up to 12. Now listen, guys, are you listening?
I'm listening.
Remember, if we want to talk about a 27-sided figure, we call it a 27gon. Might we talk about 27gon? Why not? Who cares? We can. They all operate the same way. They all use that formula as long as it's a regular whatever-a-gon.
Okay, it's regular as long as there's not any like angles that are above, like.
It's regular if all of its angles are congruent to each other and all of its sides are congruent to each other. So like a rectangle is not regular. Like a rectangle like this is not regular. Even though all 4 angles are 90, all sides are not equal to each other.
So regular is like what's it called? Equilateral
And equiangular. Yep, it has to be both.
Or a regular rectangle would just be a square.
Yes. Okay, so this is a regular hexagon. Regular hexagon. So again, I'll give you one bit of information. Here are your choices. I can give you one side. I could give you the entire perimeter. I could give you the apothem, or I could give you a radius. Oh, a radius. Okay, let's try a radius. So, remember, the radius goes from the center to a vertex. What do you want the radius to be? 6, okay. That is the only bit of information I'm going to give you. You can find the rest. So, I still am using 1/2 little a times p. Just this time, I don't have little a and I don't have p. Too bad, so sad. However, let's go ahead and draw in that apothem, because that usually helps. So I don't know what you are yet, so I'm going to put you as A. But I now have a right triangle. There's stuff I can do with right triangles. Yes.
Wouldn't the area or the length of each side be 6 divided by 2 as equilateral?
Who is equilateral?
Sorry, each side, if you like,
So if I drew this one?
yeah,
Yeah, we can draw this one.
then you could do a 30, 60, 90 triangle.
Whoa, 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 whoa. How do you know that these are 30, 60, 90s?
Isn't there like a weird formula for
Every angle is 60 degrees.
I know it's 75 degrees.
It's because, isn't it, aren't they all 60? No, they're all 60.
they're all 60 degrees and now 30. So it is 30.
Okay, let's go back. Can you tell me what the measure of that angle is? Where are you getting 150 from?
I know it's from, I think it's from some formula.
We did learn some formula.
I just don't remember what it was.
Yes. Okay, guys. So you are going to need to bring out some old knowledge. We talked about regular polygons in the past. Guys, are you listening? We talked mostly about their angles, the sum of the interior angles, n minus 2 times 180. Remember that? And then if I want to find the measure of one of those interior angles, if they're all the same, I can do n minus 2 times 180 divided by however many sides I have or angles, right? So this is a 6-sided figure. So if I do n minus 2 times 180, that means the sum of all the angles in a hexagon is 720, and then there's 6 angles in a hexagon, right? So if I divide by 6, that means each one of these angles is 120. So it just so happens, because we'll do an example in a minute that's a pentagon, for example, and it's not going to work out this same way. But in this particular case, if these are all 120, so this one, guys, does just so happen to be a 30, 60, 90. Oh, great question. So let's write it out again to refresh our memory. To find the measure of one interior angle in a regular polygon, because you will need to do this a whole bunch. You're going to do n minus 2 times 180, and then you divide it by whatever n is.
I remember that.
Yes.
What is that for? To find the measure of 1.5.
Yes.
So you bisect can you go back to the
Does everybody have this?
So does it bisect?
Yes, a radius will bisect the angle that it goes to. So now each whole angle is 120, that makes 60. Same thing up at the top, that's 30. So now I can find everything I basically need, right? If the radius is 6, isn't the radius really the hypotenuse of my triangle? Which means that the short side here would be 3, because it's just half, right? Right? Are you guys with me? So then that means that A would be 3 root 3. Yes.
Wait, why is it 3?
Isn't the short side half the hypotenuse in a 30, 60, 90? Yes. Yes.
So is this just random that it works out that the radius is the same as the side length?
So it happens in a hexagon only.
Okay.
But it will happen all the time in a hexagon. So if you heard that, hexagons are super cool because it saves you a whole bunch of time. The radius and the side lengths end up being the same. But don't get too used to that, because I'm telling you, like I said, once we try a pentagon or an octagon or a nonagon, those same things don't hold anymore. So there was our formula again. We still have to finish this problem. I think we're almost there. I at least have enough to find all the pieces. So now I know what the apothem is. It's 3 root 3. And then the perimeter, be careful, would be 36, right? Here is a common mistake. Are you listening? A common mistake is to do 3 times 6, but 3 is only the measure of this little piece, right? It's not the whole side. The whole side is 6 times 6 is 36. So be careful that you are using the entire side to find a perimeter and not a partial side. Which means that this final answer is, what's 18 times 3? 54? So 54 root 3 units squared. I love these ones, I gotta tell you. They're so fun. Okay, what shape you wanna do now?
How about a shape that has 40 sides?
Let's do octagon. Okay. Octagon. So here's an easy way. If you're having trouble drawing an octagon, it's kind of easy because you just do straight, slanty, horizontal, slanty, slanty, slanty. Yeah.
Just draw a bunch of lines and move towards each other and hold it. Put a dot in the middle and draw.
Okay, guys, I'm going to give you one bit of information again. Have your choice. How about I give you the whole perimeter? So all you have to find is the apothem. I'll even make it easy. Let's say that perimeter is 80. So this is a regular octagon with perimeter equal to 80 meters, let's say. And I want you to find the area. You're still going to do 1/2 little a times p. Well, I already gave you the perimeter. All you have to find is little a. Oops. Correct. I would start off by figuring out the side lengths. So, each side length absolutely will be 10. All right, now that I have each side length, great. I do need the apothem, so I'm at least going to draw it in. So from the center, remember it drops perpendicular to a side. So this is the length that I'm trying to find right there. Well, true to form, I'm probably going to want to draw myself a right triangle so that I can do right triangle stuff by drawing in a radius. I don't know what the length of that radius is right now.
But it's 5 for the.
Ooh, that's right. So that apothem did bisect that side. So this little piece right here is going to be a 5. Now, excuse me, I don't know that this is a 30, 60, 90 triangle. Or a 45, 45, 90. Or any other cool special right triangle. In fact, it's probably not any of those. But, doesn't mean I can't do it. I'm going to start off the same way that I did with the hexagon. Didn't we try and figure out, okay, well, what's the measure of one of these angles?
135.
Ooh, 135. Where did that come from?
My notes.
Oh. Well, smart man though, right? Why work harder than you have to? But this is the formula that you're using. So it's just that n this time is now 8. So if I just pop it in and make sure that we're good, divide by 8. Yes, I agree, 135. We're good? So each of these angles all the way around is 135 degrees. Inconvenient that it's an odd number, but whatever. So what's going to happen when I get to this one? Yes, it's now getting bisected. So half of 135 is what, 67 and a half? Okay, so this angle right here.
Can you just call it 68?
No!
Okay.
Sorry, that was a strong reaction, but no. No. 67.5.
Didn't you tell us at one point to like round up?
You're a final answer you can round. But I'm going to use this number to find this number. So if I round this, now this number is so much more off. You know what I'm saying? Yeah, you should not round until you have an answer and you're just rounding your answer. Yes. Oh, I just heard something. Say it again. Right. This is not a special right triangle, so I'm going to have to use one of my trig ratios. Another reason why I love these problems because it's such a good review, right? You have to think about all this old stuff. Love it. Okay, so which ratio would I use? Tangent in this case, right? Because I'm dealing with the opposite and the adjacent side. I don't care about the hypotenuse in this case. So tangent of 67.5 would equal the opposite over adjacent. So that would be A over 5. And then I'm just going to go ahead and solve for little a. So if I want to be extra specific here, since Nate and I just had this conversation, right? That's what I get for A, right? So look at what I have in my formula. I'm just missing that. A half times A is just 40, right? So your best bet, if you want to be as accurate as possible, leave that in your calculator and just times it by 40, right? And then I'm only rounding the one time at the end. So times by 40, there's my area. So let's round that to the nearest, let's say 10th. 482.8. And we're in meters this time. Now, yes.
And if probably would tell you what to round it to, or just do you always assume?
Well, I will probably ask for an exact and a rounded. So if I ask you for exact, what are you going to write? Do not ever give me all the decimals on your screen. That's never what I want. Ever. I don't want you to sit there and write down 10 decimals from your calculator screen. What do I write, Jared? Oh, sorry. Go ahead. Did you have a question? Oh, okay. Here's how you write an exact answer for this. So if I go back up here, well, go back. Actually, really go way back to here. Isn't A equal to 5 times this tangent? Right?
Yeah.
So, 1/2 times 5 times the tangent of 67.5 times 80. And now you could just simplify and say, what's 40 times 5 is 200? 200 times the tangent of 67.5. That's an exact answer right there. You have not rounded anything. I know you're like, but that's a decimal. Well, that really is half of 135. So I didn't round it. That's really what it is. That's exact. And then that would be a rounded answer. Yes?
How many points would we get taken off if we left it as like anything above that?
Oh, I don't know.
Like would that like just would that like horribly hurt us if we forgot to?
I doubt it, but why wouldn't you just simplify it, right? You mean and this is what you would leave?
Yeah.
Don't do that. Put them together. The problem that you run into with doing something like that is if I'm grading it quickly, I'm going to be like, what the heck is that? When I know that the answer is supposed to be this. So unless I stop and take the time and go back and look through everybody's work, you're more likely that I just think it's wrong. Even though, you get what I'm saying? So always just simplify your answer, and then it just saves everybody so much time. Okay. Another shape? Why not? Why not? Why not?
7.
Octagon.
A 7-sided figure?
A heptagon.
Ooh, a heptagon. Now, here's my other advice to you. I can't draw a heptagon. If you can, great. I can't. Guys, look at this diagram right here. I don't even really care about any of this, right? Who even cares? It has nothing to do with my problem. The important stuff is kind of just down here. So if it's a 100-sided figure or a 30-sided figure or even a 7-sided figure that I can't draw, I literally just do just this bottom part. I don't even care about the rest of the shape. What does it matter? It doesn't matter. What piece of information do you want for this? What haven't I given you? Oh, I don't think I've just given you the apothem. How about I do that? So here's the apothem. This is we got to put what it is. A regular heptagon with apothem. What do you want it to be?
12.
12. You got it.
Thank you. 7 sides.
That doesn't look like a G at all. There we go. So great. This time all you need is the perimeter. Well, that can't be that hard. Or is it? What is it?
7, 5, 5 times 180, 540 plus the 620. Like this. No, it's 360 plus 140. 540, 540.
Ooh, yeah. This one's particularly nasty. Yeah. So. Yeah, that's the measure of one of my angles. Ooh.
Thanks for choosing it.
So, well, I mean, if you want to, I don't think I would ask you about this one in without rounding, because it would be annoying. But you could do I have 900 divided by 7 gets me that, right? So that number, without rounding, is 900 sevenths, right? So what's half of that? 900 14ths. So if I really wanted to not use decimals, I could do it by using that as the fraction 900 14ths degrees. I'm never going to ask you that, but I could. Let's, for the purposes of this problem, let's say we can round this angle to the nearest tenth. Yeah. Go so fast. So this angle, they're each 128.6-ish, but I have to divide it by 2. 64.3. All right, so if that is my angle there, you still have to find perimeter, right? I have little a is 12, but I still need the perimeter. What am I going to do to find it? Jared? Yes, I'm looking for this piece. Once I have this piece, remember that I can double it and then times it by 7. Or you could just take this little piece and times it by 14. Either way, right? You're doing the same thing. So that's going to be tangent. Tangent 64.3 equals opposite over adjacent.